Yeah, good evening, everyone. So, Chennai camps, let's start off. So, last thing we did was this the types of vectors. The next one. So, in types of vectors, right, there is one more format called a pseudo vector, which is quite important considering, whenever rotation is involved. Pseudo vector. Pseudo means false. It is not a real direction. If you remember in the beginning, I was telling you, right, the vectors ka chapter was actually created for convenience, meaning people observe there are certain things. And they said, like, if it is this way, it is better. Like, area is a vector quantity. So let's see what is the pseudo vector. It is also a kind of a thing which was created for convenience. The pseudo vector, it does not give us, we're going to use this in rotation and circular motion. It does not give us the actual direction. Right? But gives us the sense of rotation. Right? We find the direction by using right hand rule. Where the curl of the fingers. So if you take your right hand and if you make a fist, the fingers which are curling, right? The curl of the fingers gives the rotation, and the thumb gives you the direction. So this blue one is the rotation, and the thumb gives you the direction. So what is this exactly? The problem is, whenever particles go in a circle, we have a problem. Look at this thing. Consider a particle going in a circle. Now, when this guy is going in a circle, when you're here, which direction is this pointing? J cap. When you're on the top, you're pointing minus I cap. When you're on the left, you're pointing minus J cap. Here you're pointing I cap. You're getting every instant the direction is changing. At every instant, the direction changes. And this is very inconvenient. Like, if someone asks you, how is the particle going? What will you say? I cap, J cap, meaning it is changing every moment. It is very difficult for us to, figure out what the hell is happening there. So it is inconvenient. So people came up with something more simple. At every instant, the direction changes. So what these people did, we used a right-hand rule and we created a approximation. So this is what we do. So if a particle is going like this, let's say particle goes 2 revolutions per second. So this is how the direction is given. We write this thing as 2 revolution per second k cap. So the k cap indicates the direction of the thumb. I'll give you examples. And the curl of the fingers gives you rotation. Means you're saying the particle is having 2 revolutions per second k cap out of the plane. Meaning, this is what you're doing. The particle is going like this, but you're saying the direction is this. You getting that thing there? That's not the actual direction, right? Is the particle actually going in k cap? The particle is going in xy plane. But by choosing a k cap, you're simply saying the rotation is that way. The particle is going in xy plane. So if you see here, particle moves in xy plane, but the direction is z axis. That's why we call it a pseudo vector. It doesn't give you the actual direction, it gives you the sense of rotation. So especially pseudo vector is useful, right? Whenever you're dealing with rotational quantities. For example, if I say body is rotating 3 revolutions per second minus I cap. What is the meaning of this? Means put your thumb along minus x-axis. So if this is x, this is y, and this is z. So put your thumb in this direction, and the rotation will be perpendicular to this. So the particle is rotating in which plane? To be more precise, it's rotating like this, now. You're getting how it is rotating? Put like this thing. Put your thumb along the negative x-axis and make your fist like this. You can see my screen. So this is minus I cap. So my fingers are rotating like this. So this gives you the rotation in and out. The particle is going into the paper and coming out of the paper. Are you getting how the direction is? Getting it? And this thing, right, it is not only here, it happens at multiple places. Think of like this. For example, if you take your bottle ka cap. Now look at this thing. You want to remove the bottle cap. So cap should go which way? Up. So put your thumb up. This gives you the rotation of the cap. Meaning if you rotate the cap this way, the cap is going to come out. You want the cap to go inside, you need to push it down. So put your thumb down. So this tells you which way you should rotate the cap. Kabhi hua you're confused which way to rotate the cap? Especially when you're tightening a screw or removing a screw from a system. Kabhi confusion hota hai na, should I rotate this way or rotate this way? Getting it? So if you see, all these are right-hand screws. They actually obey the right-hand rules. When you're opening your water tap, when you're opening your bottle ka cap, all these are right-hand screws. So if you want the cap to come out, right? If you want the cap to come out, this fingers will give you the rotation. Matlab, if you rotate the cap this way, cap will come out. You want the cap go inside, rotation is this way. So you have to rotate this way. Is that making sense? So basically, this is the same as the rotation of the screw. So if you want the screw to go this way, so put your thumb along this and rotate. So this rotation has to be this way. Is this clear, everyone? What is the meaning of a pseudo vector? Can you tell me what is the rotation of your fan right now? The fan in your room, it is rotating, right? What is the direction of the fan? Pseudo vector. How is the fan rotating? Like this, right? So put your fingers along the rotation. It will be down. Isn't it? Check it out. Use your right hand, huh? Use your right hand. So the fingers should go in the direction of fan ka rotation. The thumb will point the direction. What direction are you guys getting? Down or up? You're getting down? How is the fan rotating? Your fan is rotating like this. Isn't it? Your fan is rotating like this. In and out. In and out. So put your fingers in and out. Thumb will come down. Archana, did you get the direction? Anyone got confused with this? Please ask me. So the pseudo vector ka meaning is it is more of a convenience. If you don't use a pseudo vector, the problem is you have to define infinite directions. every second direction changes, it becomes very inconvenient. So for convenience sake, what people did, they simply created something called a pseudo vector, which is not real, but it gives you the rotation ka direction. This is how we use the pseudo vector. The curl of the fingers gives the rotation, the thumb gives the direction. So this is not a real vector, but a false vector, but it is convenient. It saves you from infinite directions. Is this concept clear, everyone? So next time when you open a screw or when you open a water ka tap, you know how it works. Same thing. See, if you want to open a water ka tap, let's say it is like this. So for the water to flow, the tap should come out. So you should know how you should rotate. At least next time when you're opening a screw, you won't be confused which way to rotate. Clear with this? But this thing, doesn't work for Camlin marker. If you have a Camlin marker, try to open the cap. वो ink refill करने के लिए भी open the cap ना. That's actually a left hand screw. You can check it out. Camlin marker is a left hand screw. You have to rotate with the left hand you have to use. It actually becomes tight if you use right hand screw. Camlin marker is actually a left hand screw. That is because you don't want to open the cap. You want to open only when you want to refill. So that way. Clear with this? So one time now, when long back, when I used to stay with my friends some 10 years back, one day, right, we are mixie kuch kharab ho gaya tha. So I said, yeah, let's buy a new one. बहुत पुराना है, 6-7 years हो गया. People are like, no, we are engineers. We should repair it and get it done. I said, यार मर जाओ, मतलब जो करना है करो. I don't give a damn. These people opened up, सब किया. It started working and people were quite proud of it. I said, like, Arun, हमने क्या बोला था? We did it. We are IITians. We got it. I said, jump somewhere. हो गया. They started using the mixie. They're cooking. Sunday था. So after 10-15 minutes, suddenly there's a big sound. वो तो मिक्सी है ना, मिक्सी का कप के inside, if you see, there is this thing which is there to rotate. That thing came out. And came out. Everything was a mess. Everything spilled everywhere. तो चुपचाप order किया बाहर से food. Right? So cooking का thing was gone. हो गया ना. अभी I told them, यार, let's buy a new one. Amazon से order करते हैं. नहीं, we need to do research why it went wrong. I said, मर जाओ, मतलब करना करो. I said, people have no work only. People are so bored. You're doing all shit things करके. Then even I was fascinated. हुआ क्या exactly? So we opened it up and we saw what these idiots did. If you see in the connection, the circuit में, so normally the wire is supposed to be connected like this, a positive and negative. While connecting, they connected the terminals in reverse. It's an AC motor, right? So the thing, what was happening, वो नीचे का जो screw है ना, there is a screw here. If you observe ना, next time open करके देखो, in that thing, there's a screw which fits here. So when you rotate the, this machine in one direction, normally if you see the machine always rotates in this direction. That is because the screw will keep getting tighten and tighten and tighten. You're getting? No matter how much you use, वो tight होगा. But because we reversed both the wires, what happened? The machine started rotating in this direction. The screw came out. The whole thing just flew everywhere and everything was a mess. So inside there is a polarity. You have to keep the wires in a proper format. If you reverse the polarity, it will start rotating in the reverse direction. So that is what happened with that thing. And people were so proud. You said, yes, we figured out the mistake. Then we went and brought the new machine. People didn't have energy to repair it again. Clear with the pseudo vector? So that is a major practical application. Use your right hand rule and you'll figure out how the screw goes. Next thing. Addition and subtraction of vectors. So it is straightforward. So whenever you're adding vectors, so if you have AX is AX I cap, AY J cap, AZ K cap, and you have vector B bar, which is BX I cap, BY J cap, and BZ K cap. So if you're adding the vector A bar plus or minus B bar, so if you're adding, you add the X components. So basically you add all I's together, you add all J's together, you add all K's together. Just be careful. Don't mix up I and K. Meaning, to give an example, more crude example, think like this. I have 3 apples, I have 4 mangoes, and I have 5 watermelons. I have 2 apples, I have 1 mango, and I have 2 watermelons. When I add them, you add apples, you add mangoes, you add watermelons, right? You don't add 3 apples plus 1 mango is 3 apple or mango. You don't create a new fruit. So the same way, I cap, J cap, K cap are independent of each other. You don't mix up I caps with K caps and K caps with I caps. I caps together, J caps together, K caps together. Whenever you think about that, think about this apple and mango. It's like completely different quantities. So when you add them, you subtract them, you subtract them. Next thing, resolving a vector. This, if you ask me, is one of the most important thing in vectors. Not vectors, matlab every chapter it comes. Every chapter in mechanics, this is the concept. You resolve a vector in components and forces. Idea is easy. Applications are good. So whenever you have a vector, so let's say this is O, this is A, and this length is A, and this is theta. So indirectly, I'm asking you to find the coordinates only. So what is the coordinates? So this guy will be A cos theta. This will be A sin theta. So we write this vector OA bar as A cos theta I cap plus A sin theta j cap. That's how we resolve a vector. Meaning this vector can be treated as a horizontal component, a vertical component A sin theta. Meaning this and this resultant is that. Understood? So the I cap component and the j cap components. Whenever you have a vector at an angle, indirectly I'm finding you x and y coordinates, nothing else. So whenever you resolve a vector, that's what you do. Have a look at this. Any doubts on this? Let's say a question. Meet, clear with this? Brijesh, Pushkal, clear? Yes. Om, Kaushambi? Perfect. Let's see a question. So this is A, which is 10 root 2. This is 45. This is B, which is 10. This is 37 degree. This is C, which is 10 root 3, and this is 60 degrees. This is D, which is 4 and 30 degrees. Find A bar, B bar, C bar, D bar, 2A bar minus B bar, C bar plus 2D bar. Let's get all these things. Means you have to give me the answer in terms of I caps and J caps. So I gave you magnitude, I gave you angle. You have to find me everything in terms of I cap and J cap. And find me 2A minus B bar and C plus 2D bar. Let's get this. Just to give one example. So if you take A bar, simply I'm asking you horizontal, vertical. Indirectly, I'm asking you to find X and Y coordinates for everyone. And then write X I cap and Y J cap. Let's go. I'll give 2 minutes for the ABCD. Anyone not clear with the question, please ask me. Okay, let's see the first one. So you have to go like this, and you have to go like this. So this is 10, and this is 10. So A bar is 10 I cap plus 10 J cap. I hope that was clear. For the second guy, you will go up and then you go left. You just imagine you're traveling from there to there. So 10 cos 37. This guy is 10 cos 37. Cos 37 is how much? 4 by 5. So that is 8. 10 sine 37. That is 6. Meaning P bar, you are going 6 units backward, so minus 6 I cap, and you're going 8 upward, which is 8 J cap. Please be careful with the signs. Don't mug up this formula. Ye formula mug up mat karo. That is because theta can be different, isn't it? What if I give theta from here? Then it will be A cos theta J cap and A sin theta I cap. So don't mug up that formula. What I want you to remember is divide the components. You know, you're traveling up which way? 8 y axis. So 8 J cap. You're traveling 6 which way? Backward, the minus 6 I cap. Are you getting? So be careful with the signs. Chalo, get C and D. So just imagine like that. From origin, you're going back and then you're coming down. So just find the distances. If you're going back, it is minus I cap. If you're going up, plus J cap. Down is minus J cap, and you're done. Get C and D. For C, it is 10 root 3 cos 60. This is 10 root 3 sine 60. So C bar will be minus 10 root 3 cos 60 I cap minus 10 root 3 sine 60 J cap. Cos 60 is half, so minus 5 root 3 I cap. Sine 60 is root 3 by 2, so 15 J cap. Please check your answers. For D, you travel like this and like this. So this is 4 cos 30. This is 4 sine 30. So D bar is 4 cos 30 I cap minus 4 sine 30 J cap. Cos theta 30 is root 3 by 2. So 2 root 3 I cap, and this guy is 2 J cap. Easy. What else did I ask you? 2A minus B and C plus D. 2A minus B and C plus 2D. Get them. You just have to add them. Finish off. I'll give you a minute. Any doubts on ABCD, please ask. You should know how to take components. Quite important. Matlab, literally, you will encounter this from every chapter. Huh? Kinematics, NLM, friction, work power, and every chapter you'll see this thing, components. If you don't know how to divide vector components, you will have a problem in mechanics. It's not tough. You see, it is only x-axis and y-axis. But if you're still confused, please ask. Don't hesitate. Ashmit, clear with this? Ashmit, clear?
Yes, sir.
Yeah. Finish off. 2A minus B and C plus 2D. Okay, 2a minus b is nothing but 2 times a, which is 10 I cap, 10 j cap, minus b minus 6 I cap plus 8 j cap. So you just have to add it appropriately. That guy would be 26 I cap. That would be 20 minus 8, 12 j cap. Got that? Yeah. Plus 12, Naresh, Ashwath. See where it went wrong? C plus 2d, this thing looks more messy. Minus 5 root 3 I cap minus 15 j cap plus 2 times 2 root 3 I cap minus 2 j cap. This is minus 5 root 3, 4 root 3 minus root 3 I cap minus 15 minus 19 j cap. Please check. Any doubts on this? This is the easy stuff. Let's see some applications. Clear? Turn in the page. Anyone not clear with this? Devansh, Arush, Mridul, all got this? Clear, na, Archana? Kaushambi, clear with this? Perfect. Next thing, equilibrium. More than that, let me teach you something else. Let's take components. I'll show you that. Wait. Let me take more physical situations. I think that will give you a better idea. Let's say we have a example. I'll show you how the situations will look like. Let's say this is angle theta. This is a body here. And let's say it has a mass mg. Okay. So we need to find the components of this thing. So this is mg. Let's say if someone has chosen this as your x-axis, right, and this as your y-axis. You can choose your x and y axis any way you want. So see how we get the angles. This is theta. So this angle would be 90 minus theta. So this angle would be theta. So when I ask you to take components, this is what you do. So this guy, the side which is touching theta will be the adjacent side. This would be mg cos theta. That's how you remember which is adjacent side. Whichever side the angle touches is the adjacent side. This component will be mg sine theta. So that means this diagram can be written as, so whenever you have a block of mass m on an incline, you can treat this thing as mg sine theta, and you can treat this as mg cos theta. You're getting? The mg vector can be split into two parts. So in this, which component is responsible for sliding? The sine theta. Making sense? So components will be useful this way. So like this, so I will give you forces. We have to divide in terms of components and show me. Okay, let's see one more. Now you try. Everyone got the idea what we're going to do? Let's say we have two inclines like this. This angle is theta, this angle is theta. And we got a ball stuck between these two. यहाँ पे ball stuck हो गया. So here there is a force here, N1. So N1 is the force, this is perpendicular. So N1 is the force due to this wall 1. N2 is the force due to wall 2. So if I choose this axis as x-axis, and this axis is y-axis, means regular x and y-axis. Can you find N1 and N2 in terms of I cap, J cap? Let me do one thing. Let me give some numbers. N1 is 10, and let's say N2 is 20. Just an example. Find N1, N2. Find N1 bar, N2 bar. You getting what I'm asking? 10 cos theta, I cap, 10 sin theta, J cap, ऐसा कुछ. So if you can tell me answer like this, na? N1 cos theta, I cap, N1 sin theta, J cap, that will be good. Numbers are fine. If you want, I can give you numbers or I can remove numbers. The answer give me in terms of N1 and N2. Is this clear, everyone, what I'm asking? So on this ball, there are two forces, N1 and N2. So there's a wall 1 and a wall 2. The ball is stuck between them. The answer will come in terms of theta. Should I show you for one? N1 is easy. Listen to this idea here. What I'll do. I will extend the vector backward. If this is theta and that is 90, what is this angle? 90 minus theta. Agreed? So this is the horizontal component. This is the vertical component. So ये कितना होगा? N1 cos 90 minus theta. Or you can write even this as theta. Either way it would work. So this is N1 cos theta. This is N1 cos 90 minus theta or N sin theta. Is that fine? So what is N1 bar? So N1 bar is minus N1 sin theta I cap plus N1 cos theta J cap. This is what I was asking. Agar N1 number diya, you will write 10 and 10 here. That's it. That is only catch. Sure, how I did for N1? Can you do for N2? This is what I was asking. You need to find components like this. So components exam mein aisa aayega. No one will ask you find A bar, B bar like this. This is boring. This is what you're interested in. How do you do for N2? Same thing. I will just drop this perpendicular like this. This is 90, na? This angle will be how much? 90 minus 2 theta, isn't it? So this angle will be 2 theta. Now be careful, ये N2 था. So if that is 2 theta, this is 2 theta. So the components will be this guy will be N2 cos 2 theta. This guy will be N2 sin 2 theta. Therefore, N2 bar will be N2 sine 2 theta I cap minus n2 cos 2 theta j cap. Clear? All clear with this? Let's see one more. Any doubts on this? How to get the components? I hope this is clear. Let's see one more. So we have 3 balls here. They got stuck between 2 walls. So these are identical spheres of radius r. So these are 2 walls. So this distance between the walls is 3r. Okay. Let's call this ball A ball. Let's call this ball B ball, and let's call this thing C ball. Now on this ball A, at this point, there's a force like this. Let's call it N1. On this ball C, there's a force like this. Let's call this thing N2. Remember, these forces are center to center. Huh? These forces are joining center to center. This is A ka center. This is C ka center. This is B ka center. So the forces will be always toward the center. If I choose this as my x-axis, this is my y-axis. So x and y standard regular x and y-axis. Find N1 and N2. N1 bar and N2 bar. Radius of each sphere is r. Meaning they won't give you angles. They expect you to find the angles on your own. This much information is there. Distance between the walls, radius of each sphere. Are you able to visualize the diagram how the balls got stuck inside? So you need to find that N1 and N2 ka components. Try. Anyone didn't get the diagram, please ask. I'll give you a hint. Indirectly, you know what I'm asking? If I can find this theta, isn't my job's done? If I can find this theta, my job is done. Na? If I can find this theta angle, theta 2, theta 1, my job's done. You just need to find that theta. How will you get the angle of this N1, N2 with the horizontal? Think. I'll give you 2 minutes. Think about it. It's a Bhautik question. When we are in a chapter called Laws of Motion, there I'll ask you find N1 and N2 ka values. Did anyone figure out the angles? See. Forget about all these things, okay? N1, N2 and stuff. What is this distance from this wall to the center? What is the distance? R. So from center to center, what is the distance? 2R. R plus R, no? Agreed? From center to the wall, what is the distance? R. That means from here to here, what is this distance? R. So in this triangle, what is cos theta? Adjacent side R by hypotenuse 2R. Theta is 60 degrees now. Is that making sense? The total length is 3R. If this is R and this is R, this should be R in the middle. And this slanting length is 2R. So cos theta is half. Is that making sense? I can do the same logic here also. This angle also will be theta. This angle also will be theta. Because this also will be 2R and that also will be R in the basement. So actually all angles are 60 degrees. Is that clear, everyone? Then you are done with the question. So this is N1. This is N2. So indirectly, N1 is like this with 60 degrees. N2 is like this with 60 degrees. So if you take the components, this would be horizontal, this would be vertical. So N1 bar will be minus N1 cos 60 I cap plus N1 sin 60 J cap. You can simplify. This guy would be this way and this way. So N2 bar would be N2 cos 60 I cap plus N2 sin 60 J cap. Please check. Once you got the angles, question becomes quite easy. Getting the angles is the main thing. So this length here is 2R. Clear? Any doubts on this? A bit of a geometry. This is how they'll ask you to get components. Clear, na, Arush? Archana, clear with this? Om, Vihan, clear? Shashwat, Meet, Brijesh, Devansh, got it, no? Next thing, equilibrium. What is equilibrium? When sum of the force vectors is 0, we say the body is in equilibrium. If sum of the force vectors acting on a body is the null vector. Null vector meaning the zero vector. The body is said to be in equilibrium. That means if you have a body and you're applying F1 bar, if you're applying F2 bar, and if you're applying F3 bar, so if you add all the vector quantities, F1 bar plus F2 bar plus F3 bar is 0 bar, null vector. So the meaning of this is, if you divide these components into I cap, J cap, K cap, the components in each direction should cancel out. Means all I cap should cancel, all J cap should cancel, all K cap should cancel separately. Component of forces in any direction cancel out. Clear with the meaning of this? Let's see a question. Any doubts on this page? Great.
Just a second.
Yeah.
Done, sir.
Yeah. So let's say we have a body at the origin. So there is one force here, 20 root 2 newtons at 45 degrees. There is a force here, F1 at an angle theta. And there is a force here, let's call F2 at an angle of 37 degrees. Let's say this is 25 newtons. So the question is, find F and theta if body is in equilibrium. You can also say body is at rest, meaning it's not moving. So there are three forces, 20 root 2, 25, and F. These three together are cancelling out somehow. So find F and theta if the body is at rest. Let's try this. Question is clear, right? Straightforward. Should I help you? First, just divide the components. See, don't need to write I cap, J cap. That's a waste of time. There's a better way. See, if you divide this into components, the red one, what are these components? That would be 20 root 2 cos 45. This would be 20 root 2 sine 45. So basically that is nothing but 20 and that is nothing but 20. For this guy, it is 25 cos 37, which is 4 by 5 or 20. This is 25 sine 37. That is 15. So, see, I'll write it again. So I can write this thing as 20, 20. And the horizontal direction with this guy is f cos theta. This guy is f sine theta. This guy horizontally is 15 and this guy vertically is 20. Can I just write like this? Keep it vertical, horizontal, just split them apart. Now you tell me, for the body to be rest, all the vertical should cancel out and all horizontal should balance out. Isn't that what you mean by equilibrium? Horizontal forces should cancel, vertical forces should cancel. So in the vertical direction, what are the forces? The 20 is balancing with 20 plus f sine theta, meaning f sine theta is 0. That means either f is 0 or theta is 0. So if we take horizontal, 15 is 20 plus f cos theta. So f cos theta is minus 5. So one thing is clear, theta is 0, f can't be 0. If theta is 0, that means f is minus 5. What is the meaning of minus 5? Or we can also say theta is 0 or 180. Both of them work. What is the meaning of f minus 5? F is not acting this way, f is acting this way. Are you getting it? The direction is reverse. Negative indicates the direction is opposite. So the signs take care of it. Is this clear, everyone? Or you could have said here also theta is 180. Sine 180 is also 0, meaning theta is completely 180 degrees. So f is pointing this way. Either way it works. Easy? Let's see one more. Any doubts? Anyone not convinced with this? Please ask. Mridul, clear, na? Devansh, Arush, clear. We have a block here like this. We have two strings. This is 53 degrees. This is 37 degrees. And let's say this is some 5 kg. So if you look at the forces, so this string is pulling with T2, this string is pulling with T1, and this weight is 50 kgs or 50 newtons. So T1 and T2 are tensions in the string. Find T1, T2. The block is at rest. Are you getting the diagram? So basically you tied the block with two different strings. They're making angles 53 and 37. Tensions are T1, T2. So you have to find T1, T2. Weight is 50 newtons. This is how questions will come. This is how we need components. So resolving a vector into horizontal vertical is a most important one. Entire mechanics mein that is like a basic thing, obvious hai. So let's get sufficient practice with this. You should be quite comfortable. Find T1, T2. Just give it a try. Just get some water and come. What is the answer? 120 and 90. Okay. Anyone else got that? Try. I'll give you a minute more. 62.5. Okay, we have two different answers. Let's see. Look at the angles. If that is 37, this is 37. Alternate angles, that is 53, this is 53. So if you look at the components on the block, this guy is 50 downward. So horizontally, this is T2 cos 37. The vertical is T2 sin 37. I hope you're getting that by now. Whichever side touches the angle is adjacent side. The other one automatically becomes a sine. So this is T1 cos 53. This is T1 sin 53. Again, equilibrium, the vertical forces should balance, horizontal forces should balance. So horizontally, T1 cos 53 is T2 cos 37. 57, 33 values, you need to get used to it. Cos 53 is 3 by 5. Cos 37 is 4 by 5. So 3T1 is 4T2. That is one equation. This is the horizontal. So on the vertical, T1 sin 53, that guy is 4 by 5. T2 sin 37, that guy is 3 by 5, is 50. So 4T1 plus 3T2 is 250. You can take T1 from here, 4T2 by 3, and substitute here. This is 4 into 4T2 by 3 plus 3T2 is 250. That is 16T2 plus 9T2. 3 उस साइड जाएगा तो 750. 25T2 is 750. T2 is 30. Interesting. T1 is 40. Yeah, right, Arish. Please check where you guys goofed up. If you have written this equation and this equation flips got over, you did the question. It's just a matter of solving. You must have goofed up the calculations. Check your equations. If you got the equations right, you're done. Then see where you messed up the calculations. Ask me where you're confused. Any step you're not convinced here, ask me. Multiplication, yeah. Please check any mistake. Next one. Can I turn the page? Amit, Brijesh, Mridul, Shashwat, Archana. Can be clear?
Yes, sir.
Yeah. So this is the wall. This is the fixed incline. Okay. And let's say this is some 10 kg. So if you see the forces here, this guy is pushing this way, N1. This guy is pushing this way, N2. And this height here is r by 5, and the radius of the sphere is r. So basically, if you look at the forces now, they'll always pass through the center. And this weight is 100 newtons. You getting how is the ball? The ball got stuck between a wall and an incline. Angle nahi diya. This angle we don't know, it is not given. But instead of that, they gave you the height where the ball got stuck. So wall ka force is N1, the incline ka force is N2. Find N1, N2. Are you able to visualize the diagram? The wall pushes from right, the incline pushes from bottom. So there are two forces like this. Both are passing through center. The weight is 100 newtons. First, you need to figure out the angle. The radius of the sphere is r, and the height where the ball was touching the incline is r by 5. Find N1, N2. Think. Meaning, if I can find this angle, my job's done, isn't it? N2 cos theta, N2 sin theta aa jayega. I just need to find that theta. Figure out that theta. If you get the theta, your job's done. You need to find this theta. Try, I'll give you 2 minutes. This is what makes resolution tough. Resolution is easy, but they'll not give you the data every time the way you want. You need to get the data and then resolution comes. Everyone should try. It's okay if you don't get an answer, but I want you to try. If there are 5 steps, at least figure out 2, 3 steps. In case you're feeling sleepy, go wash your face and come sit straight, everyone. Don't clean. Once you start cleaning, your body will think it is time to rest, and don't put your hand on the head. Let's try. Chal, let me help you with the angle. So from the center, this is the point where it is touching now. Let's call this some point A. So this is O. What is this length here? R. So from this base here, what is this length here? R. So from here, if you drop a perpendicular, what is this height given here? R by 5. Isn't it? Dekho na. From here, this base, if you see, okay, wait, I got the diagram wrong. I understood why you're not getting. Yeah, you can't solve. I need more data. Actually, you can't solve that. Wait. Let's make this 2r by 5 and this be r by 5. Maybe that's why you're not getting it. My mistake. I gave data wrong. Now try. The lowest point is r by 5 and the point of contact is 2r by 5. I messed up the data. It's my fault. Try. You got again a minute to get the angle. I think now you will get it. If that is r by 5, this guy will be 4r by 5. And this angle theta would be cos theta adjacent side by 4 by 5. 37 degrees now. Now you will get it. So from the ground, this is 2r by 5. This is r by 5. So the balance should be r by 5 only. Clear with the diagram? So then you're done with the question, right? So we got a sphere. So this guy was N1. This guy was N2. This guy was 100. And this guy was 37. So if you resolve the components, we get N1. This would be N2 sine 37. If that is 37, this is also 37. So it will be like this N2 sine 37. This would be N2 cos 37 and your weight 100. Look at the arrows, how they are. So who is balancing the weight? N2 sine 37 is balancing 100. Sine 37 is 3 by 5. So N2 is 500 by 3. And horizontally, N1 is N2 cos 37. But N2 is 500 by 3 and cos 37 is 4 by 5. 400 by 3. Is that clear, everyone? Please check. The main thing is getting the angle. Once you get the angle, job's done. Anyone confused with the angle, the components, or the calculation, anything you didn't understand?
Sir, can you show the question once again, sir?
Clear? Clear? Go ahead.
So just a second, sir. Just.
Yeah.
Yes, sir.
Any doubts on this? Please ask.
No,
Clear, na, Ashmit? Archana, clear, na? Let's see something even better. We got a cube. We have a mass here. Let's say 10 kg. This is tied by 3 ropes. like this. So A is the face center. It is the center of that face. So here a mass M is tied by 3 ropes as shown. So mass M is placed at the center of the cube. So this position is the center. Are you getting the diagram how it is? So you have a mass M here, 2 strings are connecting to the 2 ceilings at the back, and 1 string is connected to the front of you. Are you getting? 2 strings are connected to the ceiling ka 2 corner mein. The third string is connected in front of the wall in front of you in the middle. Now by symmetry, if you see B and C will be same. So let this be T1. This also T1. This guy is T2. Find T1, T2 in equilibrium. And because of the weight, there is a force of 100 newtons like this. So 100 Newton weight is pushing down. There are 2 strings, 2 T1s and 1 T2 horizontally. It's a cube. Matlab all sides are equal. So you have to figure out the angles from there. Let's get this. Let's see how will you visualize. How would we do this? Think, take a minute. You have to visualize the angles in 3D. Yeah? For T1, theta is 30. Which theta are you talking about? The angles are pretty weird here. Which theta? How are you defining the theta here? Just to give you a little context, see how it looks. Huh? If you actually look at the angles here, from the center, if you drop a line like this, ये समझ में आ रहा है? ये होगा ना angle. This will be an angle theta. Are you getting it? That angle is not in the plane. That angle is at an slanting length में था वो theta. So अगर इसका components ले तो components कैसा आएगा? This will be T1 cos theta This will be T1 sine theta, right? But same way, if you look at the other string का component also will look like this, isn't it? Meaning इसका भी component ना T1 cos theta will be like this, they'll be like this, Y shape में आएगा T1 cos theta. Are you getting how the angles will be? If you see now, the angles will look like this. See, the two strings are like this, right? See, the two strings are like this. You're looking at my screen. So we have two components, two T1 cos theta ऐसा होगा. T1 sin thetas will be like this. T1 cos thetas will be like this. You're getting it? T1 cos thetas are not in the same direction. To give you a little more diagram, it looks like this. See, if you make a horizontal surface now, this will be T1 cos theta. This will be T1 cos theta. ऐसा रहेगा T1 cos theta. And there'll be two T1 sin thetas in the upward direction. T1 sin theta, T1 sin theta. This is your T2 and this is your mg. समझ में आ रहा है angles कैसा है? And again, इसको ऊपर, if you look at this angle will be different again. ये alpha होगा. Now you get in the context. There are two angles there. Theta is with the vertical, alpha is the horizontal. Please look at the diagram. Chemistry, right? There is a compound called PCl5. It has kind of structure like this only. We'll learn later on. Please ask me, anyone is confused with this diagram. How did I resolve the components? So your job is finding theta and alpha. If you can find theta and alpha, my job's done. Archana, diagram is clear? Sure, no? Brijesh, Arush? Clear?
Yes.
Meet, Mridul, Devansh, Kaushambi? Anyone confused with the diagram, please ask. How to find that theta? Get it, it's just geometry there. See now how to get theta. What is this side here? A by 2, na? What is this side here? A by root 2, isn't it? It's half diagonal. Do you agree it is an half diagonal? That's an half diagonal. For a cube, if you draw like this, ये तो half diagonal है ना, center तो this is A by root 2. So from there we can get, so basically this triangle में, this is A by 2, this is A by root 2, this is theta. So if I use Pythagoras theorem, I will get, actually I can use tan theta, which is A by 2, A by root 2, 1 by root 2. This is not a standard angle. Listen one thing, I'll teach you how to use any angle from here. Listen carefully, it's not difficult. So when you got tan theta 1 by root 2, meaning 1, root 2, no? Opposite side is 1, which center is root 2. Use Pythagoras theorem, ये होगा root 3. So if tan theta is given, from there you can find sin theta and cos theta. So sin theta is 1 by root 3, cos theta is root 2 by 3. So if someone gives you tan, you can find sin and cos. If someone gives you sin, you can find, these are non-standard angles. Clear with this? What is alpha? What is this angle here, alpha? What is this thing? देखो ना. What is this side here? A by 2. what is this here? Half side, na? A by 2, isn't it? So if you look at that again, alpha is 45 degrees. So from the center, this is A by 2. This is A by 2. This is A by root 2. You can take however you want. This is alpha. Tan alpha is 1. Alpha is 45 degrees. There, you got everything. Clear? Now let's see the components. So this is T1 cos theta. T1 cos theta. This is 45 and this is 45. This is T2. So vertical mein there are two components, T1 sine theta, T1 sine theta, and there's weight 100. All got this? So in the vertical direction, 2 times T1 sine theta is equal to 100. 2 T1, what is sine theta? Sine theta is 1 by root 3. So we get T1 is equal to 50 root 3 newtons. Fair enough. Now in the horizontal direction, look at the catch. T1 cos theta ka cos 45. You have to take T1 ka again component, that Y shape ka components. So this is T2. This is T1 cos theta. And this is T1 cos theta. This is 45 and this is 45. So this directional components will be T1 cos theta cos 45. T1 cos theta cos 45. This direction it will be T1 cos theta sin 45. T1 cos theta sin 45. So sin 45 is actually cancel out. So 2 times T1 cos theta cos 45 is T2. T1 is how much? 50 root 3. Cos theta is how much? Just now we calculated root over 2 by 3. Cos 45 is 1 by root 2. Root 2 will cancel. Root 3 will cancel. We get T2 is equal to 100 newtons. Have a look at this. Are you able to visualize in 3D? Getting the angles right, how to get it? Oh, 30s and 45s nahi hai. This is some random angle 1 by root 3. I don't know how much is that. I don't need also. What I need is sin theta cos theta, which I know. Have a look at this. Any doubts on this? Is the question clear? Again, try this on your own. Huh? Meaning you want to have fun, you can do something like this. Same question, you can connect like here. You can connect one string here and one string to the midpoint of this guy. Ye B nikal do. You can connect like this. And then find T1, T2 and T3. Abhi तीनों tensions अलग होगा. Isn't it? That would be more fun. If someone wants to try, that's what I'm saying now. Physics, that's the advantage. You can create your own problems. You will say, sir, you already have enough problems in life. You don't need more, but yeah. Clear? Great. Let's see. Last one for the day. So this is x-axis. This is your y-axis. Radius is r. So we have a particle here which is going along the circle with speed u, t0. If you remember, last time I taught you how to find the position vector. Particle goes in a circle with speed u. So first thing, find the velocity vector at time t. Again, velocity vector matlab I want u something I cap, u something j cap, like that. Meaning after time t, this particle will reach somewhere here. So I want I cap and j cap. Second thing, find change in velocity of the vector. That is, I'm asking you delta v bar, which is v final vector, that is after time t, minus v initial vector. Initial vector to u j cap, you can clearly see. C, find mod delta v bar. This result is important, straightforward question in mains and bits. A particle rotates by an angle of 60 degrees. Find the change in magnitude of change in velocity. Let's get the first part. If you got the first part, you'll get everything. You have to give me velocity vector in terms of theta. You guys already know how to find theta, isn't it? Let's assume this angle is theta. How much is theta? Theta is arc length, which is ut by radius. So theta we already know. So if that is theta, this is theta. So this angle is 90 minus theta. So indirectly what you have is a velocity vector u like this, with this angle is 90 minus theta. I'm just asking to get the component. So ye hoga u cos 90 minus theta. This will be u sin 90 minus theta. Therefore, the v final, or v as a function of time t, is minus u sin theta I cap plus u cos theta j cap. V initial is at t0. If you look at it, it is pointing upward. This is u j cap. Is this clear, everyone? So I'm asking you change in velocity vector delta v bar. So that would be v final minus v initial. That would be minus u sine theta I cap plus u cos theta minus u j cap. Subtract I caps and j caps. Then I am asking you find the magnitude. This would be root over I cap ka component u sine theta square. This is u cos theta minus u ka whole square. Can you simplify that further? Try. I'll give you a minute. Have a look at this. Right? 2u sine ut. Yep. So if I simplify this, so delta v bar mod, expand this, you end up with u square sine square theta, u square cos square theta minus 2u square cos theta plus u square. Sine square theta plus cos square theta becomes 1. So that becomes u square plus u square minus 2u square cos theta. Take out u square common, that will be u root over 2 into 1 minus cos theta. Do you remember what is 1 minus cos theta? I told you this will come in again. 1 minus cos theta is nothing but cos square theta by 2. Do you remember that formula? Trigonometry ka. So substitute here. So this would be u into root over 4 into, sorry, this is sine square theta. Quite a useful result, right? Keep this in mind. So whenever a particle goes in a circle by an angle theta, the change in velocity is this. So example, let's say a particle initially here, the speed is v. It rotates by an angle 60 degrees and it becomes like this. So the change in speed will be 2v sine 60 by 2, which is sine 30. So v is the answer. That was a straightforward main sense CET level question. Clear? And quite a useful result. We are going to encounter this again in when I teach you differentiation. We're going to encounter this again. So let me give you 2 homework questions. Try them. Next class when we catch up, we are going to meet. So we'll discuss them. We have a block here. It's a cube of Seidel. Now you're trying to carry this with a load or something, with a crane. So you're carrying like this. All the strings of same length. So cube ka side is also L. The sides are also, length of this thing is also L. So this is point A, point B, point C, and point D. Let's say the mass M is 10 kg. That means the weight is 100 newtons. So the tension in the strings, since all are identical, is T1, 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 and T1. Got this? You connected the 4 strings on the corner. Then you came up with another idea. I said, yaar, ऐसा ही क्यों करना है? You said, let's not connect here. Let me connect in the centers. E, F, G, H. These are the midpoints. Now the tension will be different. It won't be same T2, 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 T2. Same block. 10 kg block, and this also will be 100 Newton. So in this scenario, find T1 by T2. Got my question? The strings are same length L. The cube ka also side is L. So case 1 you connected on the corners. Case 2 you connected at the midpoints. So the tensions will be different. So find T1, T2. Clear? Next one. This is a pretty good important question. So take some time to think about it. We have 3 vectors. A bar, B bar, C bar of magnitude 2. So all the 3 vectors have same magnitude. Angle between any 2 vectors is 60 degrees. This statement is quite important. Huh? Listen to this carefully. Angle between any 2 vectors is 60 degrees. That is, angle between A and B is 60 degrees. B and C is 60 degrees. C and A is also 60 degrees. Can you tell me how does the diagram look like? So find the magnitude of, if you add these 3 vectors, what is the magnitude of these 3 vectors? Can you tell me how will the diagram look like? Just tell me that. Now it's not a equilateral triangle. See, if you say A and B, if you say this is 60, if this is 60, then this will be 120, na?
Like a pyramid.
The 3 can't be in the same plane. Right, Archana? Dekho na. If you say this is A, this is B, and if this is 60, chalo theek hai. If you say this is C, this is 60, theek hai. But B and C is not 60, na? B and C will become 120. I'll help you with the diagram. You guys give it a try. It's a good one. It's like a pyramid. This is actually called a tetrahedron. This is A bar. This is B bar. This is C bar. This angle is 60 degree. This angle is 60 degree. This angle is 60 degree. समझ में आ रहा है कैसे? The 3 vectors are out of plane. ऐसा. A bar, B bar, C bar. They can't be in the same plane. That is the way you can get 60 degrees. 60, 60, 60. So I want you to find the resultant of these three vectors. Clear? Think about that, how to do. It's a good question. This is a pretty good one. If I have to ask you in advance, I'll ask you this question. So these are the two questions. Try them and come. So next class when we catch up, we will do this thing. Right? So this week exam will be online mostly tomorrow. I'll post it in the group. So next week exam will be till here. So like this, whatever I teach you 1 week before, so that 1 week before ka portion will be there. So the next week exam will be basic maths plus whatever vectors I taught you till today. Okay, then they'll be keep on piling up the portion like that. Then we'll have one full vectors ka mains ka test, we'll have one vectors ka full advanced level test. We'll keep writing papers. Okay, so that will wrap up for the day. So do make sure to try all the questions again once more on your own. Right? Try these two. I'll try to send you a small sheet also by tomorrow evening. Okay, with that we'll wrap up for the day. So any doubts, anything?